Okay, welcome back. So, we're going to talk about another topic of sequences besides arithmetic is called geometric sequences. So, geo means kind of like you're getting to like the geometry of things, and metric is kind of the way to measure. So, earth measure, but really we're looking for a sequence of events. And so, if you ever seen like Disney movies, recent Disney movies, or maybe The Lion King, the original one, or Toy Story, those were actually they're Pixar movies, and they actually did a lot of geometric sequencing in um, its movies. So to kind of give you a few examples before we start, I want us to take this example. And if you would like to write this down, that'd be awesome. This was actually pretty fun. So let's take a square. So a square should be even on both sides. If I don't draw my square very badly. So you have a square. And I'm hoping, if you don't know the definition of a square has equal sides on every side. So this side, this side, this side, this side should all be equal. Okay, I want us to take the area of this square. So let's call this side 1, this side 1. So hard question, what's the area? What's the area of this square? And if you say, well, it's 1 times 1. So 1 times 1 equals 1. Okay. We can do the units later. So let's take a square of area 1, 1 by 1. And I want us to kind of do something to this. I want us to take the square and now go ahead and cut it in half. So you should have 1/2 here and 1/2 there. Okay, well, take this half and go ahead and cut that in half. So what's a half of that? Well, that's going to be 1/4. Well, now take this and cut this in half. So hard question. What's going to be 1/4? So 1/2, 1/4. What's the next? Um, you're going to get what? 1/16 or 1/8? Well, how do you do that? Remember, you cut this in half. So if you go 1/4 times 1/2, because you're cutting it in half, or divided in half, I should say, you should have, what, 1/8? Okay. If you cut that in half, you get 1/16. You cut that in half, you get 1/32. If you cut this in half, you get 1/64. 181, and you can just keep cutting down until you reach the very end. So that is kind of our interpretation of a geometric sequences. And all we're doing is cutting this square in half. So 1/2 is going to be our geometric sequence. We're always cutting by half. So that's going to be what we're going to call it the R. Okay, so R is always going to be 1/2. We're always going to cut this down by 1/2. Another way that you can see it, you don't have to write this if you don't want to. If you take a line, a straight line, almost like a number line, and go from 0 to 2, cut it in half. Well, obviously you get 1. Then you cut it in half again. You get a half. Cut it in half again. You get 1/4. And cut it in half again. You know where we're leading. We're almost getting down to 0. So I want you to kind of have that in the mind. We're always going to be we're always having something a half. Now, can it go bigger? Well, of course. So, for example, our COVID, the COVID-19 virus that we're going on. Well, what if we had two people that gets infected? So, what's 2 to the 0 power? 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. Do you see what's going on? Each time that we are increasing our exponent by 1, it grows. It grows. So 2 to the fourth power. 2 times 2 times 2 times 2, 16. So every time that we increase, and so our geometric sequence, our pretty much our R here, our R is always going to be 2. So that's kind of the introduction to this. And you're probably like saying, well, I don't really get it yet. That's fine. These are just simple examples for you to look it over. Okay, so here we go. So, a geometric sequence. So let me zoom in here. So please write this down. So a geometric sequence is called a collection of objects. Remember, objects is the same as terms. I put in 2 times, in which, so cross one of those out, in which repetitions are allowed. So repetitions like that 2, to have a multiple term being multiplied to get the next term. So take a second or a minute to write that down. You might need to stop this video. That's okay. So really we're talking about that 2 that we did. We're talking about that 1/2 we had. Those are the 2 numbers that we came up with or we discovered. So that is what's going on. These are what we call the repetitions of being multiplied every time to get the next term. So for example, when I cut that square, we did it by 1. What was the next one what we did? Well, we cut it in half. Well, what was the next thing? Well, we cut it in half again. And so we keep doing that. And that half is how we get the next numbers. That's all we're doing here. We're taking whatever number we're doing with, and we're just keep going. So here we go. So let's make this a little bit fun. A rubber ball. Yes, a lot of writing in this one, but you know what? It's the language that you have to get used to, and it's the applications which you have to look out. So let's say we have a rubber ball. It's dropped from a height of 20 feet. So top of a 2-story building, a rubber ball. As the ball hits the ground, so it doesn't matter if it's cement, let's say it's cement, it comes up to only about half of its height and then continues. So for those visual people, and I'm one of them, I'm just going to make a little graph here. And I'm going to say, okay, well, this is 20 feet tall. And let's say that every time, so the ball gets let go, and it goes something like this. It hits right here. And then it says it hits the ground, and it comes up to only about half of its height. So we're going to go bounce, boom, bounce, boom, bounce, 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 bounce. And you can kind of see where it goes. So it says that it goes from 20 feet. So what's going to be right here? 10. What's going to be right here? 5. What's going to be right here? Come on, guys, you can do it. 2 1/2. What's going to be this little small one? Okay, so 2.5 divided by 2. 1.25, right? So this is 1.25, or 1 1/4, I should say, or 1 1/4. So you can kind of see what happens. So what's going to be our geometric series? Our pretty much our R, you can kind of call it. Or R is going to be our what? It's going to be always a what? A half. So that's what you're going to multiply to get the next term. So if I went 1.25 and then put that 1/2 into there to get the next point of 1 1/4, it's going to be whatever that's going to be. But that's the process of this. This is it. Right? And so we figured out the sequence right here of our ball. So we start with 20. We take a half of that, we take a half of that, and we just keep going. And that's pretty much all we're doing with geometric sequences. It's really not too bad. Something like an application, a rubber ball, or golf ball even, or a baseball, or a soccer ball. If you drop it from a certain height, it's going to bounce back up because of the force of gravity. Okay. So let's do some more of these. Okay. So first off, I want you to we don't need let's only have a couple of these first. So I tell you what, let's start with these two. So let's say, just like arithmetic sequences, we're going to do the same thing with geometric. Given the first 3 terms, identify, you can also call them elements too. Remember, elements, objects is fine. Identify if it's geometric, then predict the next 2 terms this time. So just like in arithmetic, we're saying that, okay, if it's arithmetic, is it geometric? There's a difference there. You want to be very careful, because if it's not geometric, then it might be arithmetic. Well, what if it's not arithmetic either? Well, then you probably don't have a pattern. So let's do a few of these. Okay. You can number these how you want them. I don't care. You can call this 1. You can call this 2. It doesn't matter. These are just examples. So these are just examples. Okay. So let's do the first one here. We have 2, 10, 50. So what's going on with this one? Let's see. From 2 to 10, what's going on? It looks like it jumps pretty high, right? And then from 10 to 50, it looks like it jumps, wow, it jumps a lot more. So what's going on? A good way that you could do this, if you don't see the pattern, is actually take 10 divided by 2. So look how I did that. If you don't know what the geometric number is to get from 2 to 10, what did I just do? I took the second term and I divided it by the first term. I took the second term, divided it by the first term. And what do you get there? Well, you get 5. Okay, so 5 is what we got from those two. So it grows by 5. Well, does that same thing work from 10 to 50? So you can try my method here. So you can go 50 divided by 10. So we're taking the second divided by the first, and we get cross, 5. Okay, so it is growing by 5. Oh, so you can say our value is 5. there is your geometric pattern. This is called your geometric pattern. Okay. So it grows by 5. Now you're probably thinking, well, how do I get to the next 2 then? Well, how did we do this? We took the first, divided it by the second. So this time, we're going to go take this idea, and we're going to get to the next one. And what do we think we're going to do there? So I want you to think really hard about this, because this is actually, critical thinking skills here. This is a lot of critical thinking skills. Didn't we divide here? So we divided here. What is the opposite of division? What is the opposite of division? Multiplication, right? It's multiplication. Can't see that. Area multiplication. So it's multiplication. So I want you to think about this. 50 times what? To get the next one, we're going to go 50 times 5. Do you see what I did? We divided, but to get to the next term, aren't we going to multiply instead? So for these, you know what? I don't know. You might not need a calculator. You might, but really, I don't think you do. So this would be 250. So that's the next one. So that's one term. So we want 250 times 5, and that's what we're going to get the second one. And so that should be 1,250, I do believe. Check me if I'm correct on that. So here's what you're going to put. Yes. So here's what you're going to put for your homework, actually. So you're going to put your R value should be 5. You're going to put yes, geometric. And you're going to say the next 2 terms is the next 2 terms. So yes for geometric. Yes, it's geometric. R is the 5. O is multiplying by 5. And our 2 numbers should be 250 and 1250. And that's what you're going to put for your homework. I'm going to give you a few of these. I want you to think about them. They're going to be some easy, some hard. I want to challenge you a little bit. Okay, so that was the first one. And you're probably thinking, wow, this is just a lot. Not necessarily. It's not a whole lot. You just got to do a little bit of math here. Okay, let's do some more. So let's see this one here. So what's going on with this one? So it looks like this one, probably going to say from 5 to 10. Now, for some of those students that can't really see the pattern, what did I do on the first one to get the answer? I took 10 divided by 5, right? I took the second divided by the 5. And what did I get? I got 2, correct? Well, why can't I do the same thing with this 2? What is 20 divided by 10? Which is 2. So 20 divided by 10. So it looks like 2 is going to be my answer. So that's going to be my answer. That's going to be my growth factor. You can think of it as like a growth factor. 2 is going to be my growth factor. So now, is it geometric? Yes, because it goes up by 2. Or it's multiplied by 2. So you're going to go yes, geometric. And you're going to say my R is 2. And what's the next numbers? So we want 2 numbers. And how are you going to get that? Well, you're going to go 20 times 2, which is what? 40. and you're going to go 40 times 2, which is 80. So there's your numbers there. So I'm hoping that you don't really have a hard time with this. It's actually pretty straightforward. So let's challenge you a little bit. This should be number 3, I do believe. I said 2 here, but you know what? I'm going to change it. It doesn't matter. I think I messed up on the numbering, but that's okay. Number 3 is fine. As long as you have them down, I don't mind. All right. So hope you can pause this one and do it yourself, and you get this. So hope you can pause this and then do it yourself. Here we go. From 2 to 4. So it looks like we went 4 divided by 2, which is 2. 4 to 8 looks like 2 divided by 4, which is 2. So it looks like 2 is going to be my R, my geometric part. So we're going to say yes, geometric. You're going to say R is 2, and then how do you get your next numbers? We're going to go 8 times 2, which is 16. We're going to go 16 times 2, which is 32. So there's your numbers there. Okay. Let's do some more. Number 4. So what happens with this one? And you'd be like, well, I never had negatives and positives before, but I want you to look at this very closely. Doesn't this switch back and forth? Well, this switches back and forth. This switches. And that's okay. It switches by a negative. That's going to be important. So it's going to be switching always by a -1. Because you can see how it goes positive to negative, positive to negative. So what happens? So let's go 22 divided by -11. Remember, I don't really know what this is yet. I'm going to go the second divided by the first. Well, what's the second divided by the first? Let's see. How many that goes? That's at -2. Okay, let's see if it works for the next one. -44 divided by 22. And what is that? Let's see. That goes in there -2. I guess 2s are my favorite thing today. So it looks like 2 is going to be my pattern. So you're going to say yes, geometric, and you are going to go, my R is -2 this time, -2, and you will see in a minute why this switches back and forth from negatives to positives, positives to negatives. So how do we get to the next one from -44? Well, we're going to go -44 times -2. Now, I hope that you understand this. What's negative times a negative? A negative times a negative is a positive. Okay. And 44 times 2, 44 times 2 is 88. So there's your first one. Well, let's do the next one. So we're going to go 88 times -2. -2. And I'm hoping that you're seeing this. What's a positive times a negative? I hope that you're going to say negative because that's what we've been working at. And what's that going to be? Is that 176? Looks like -176. So there's your answers. Okay. Okay. I think I have a couple more. Let's try this one here. I don't know about the numbers. Don't worry about the numbers. Just put, I tell you what, just put example is fine. Put example is fine. I messed up on the numbers. That's okay. Okay, so look at this one. Now you'd be like, 1, -1, -1, 1. I'm assuming this can be negative. I'm assuming. But let's see if we are correct. Okay, so from -1 to 1, so -1 divided by 1 is -1. Correct? Well, let's see about the next one. What about 1 to that one? So 1 to -1. What would that be? -1, correct. It doesn't really matter where the negative is on the denominator or numerator. It's still going to be the same. So you can see here and here, you see how the negatives are different? It's still going to be the same. So these are still going to be the same. So this will work. So your R is going to be -1. And you're probably thinking, well, we haven't had one that didn't work. There will be ones that won't work that I will give you. And don't worry, if they don't work, you're going to put nothing. And I tell you what, I will give you one before we leave. So how do you find the next one? Well, you're going to go 1 times -1. And what is 1 times -1? -1. So there's your next one. How do you get the next one? Well, -1 times -1. And that should be 1. So there's the next one. So there's your 2. Okay. All right. So, yes, I do. All right. So we have this one here. A little bit longer. And fractions, everybody's favorite. All right. So first thing we're going to do is decipher what happens. Now, maybe you're good at fractions. You can probably just see the pattern just like that. I don't know. But since we are not going to assume that, we're just going to assume that everybody doesn't know this. So what do we do to get from there to there? We're not too sure. Okay. So remember what I've been doing? I've been taking the first, and what have I been doing? Dividing it by the second. So I've been taking the second, dividing it by the first. And this is what you get. This is what you get right here. So I hope that you know how to divide fractions. And maybe in recent years you learned to divide fractions. Another way of looking at this, but I was taught this way. So I just go where what I know. Okay, so what do? We divide fractions. We go 1/4 times what? Don't we take this and flip it? So then we're going to go 8/1. We're going to flip. If you don't remember fractions, I do have a refresher video that you can look at for fractions. So you might need to go back and refresh a little bit, but that's for later. So remember, when you divide fractions, we keep, change, flip. So we keep, change, flip. Keep, change, flip. And what do we do now? Multiply across. So we're going to go 8 divided by 1. 4 times 1 is 4. And what's this going to be? It looks like, is that 2? Yep, 2. So it looks like we're multiplying by 2 each time. Love my 2's. So let's see if it works. Let's see if it works. So test it. So let's go 1/4. Let's go 1/4 times our 2. 2/1. Remember, 2/1 is how you write it to a fraction. 2/1 is how you do the fraction part. And multiply this across. So you get 2/4, which is 1/2. Okay. And that's correct, which is 1/2, which is 1/2 there. So it works. So how do you get your next one? How do you get your next one? So we know that R is 2. So your next one should be 1 times 2. 2. We know 2 times 2 is 4. All right. That one was a little bit of a tricky one, but you can hopefully understand how you did the fractions here. If not, I do have a video that I will send to you if you need it. All right. So that kind of does it for geometric sequences. So hopefully that answered some of your curious questions, and I will see you on the next video.